So we've met simple coordinates in 3 dimensions and a couple of examples of a really basic equation of a plane. And we just did the calculation for computing distance between 2 points in 3 dimensions. Let's look at a key graph for the semester in 3 dimensions. It's not a difficult one to talk about, and its algebra is pretty predictable, but we're going to look at the sphere. So the definition of a circle would be the set of points in a plane that are equidistant from a given point. This given point would be the center, this would be the radius. So if we just move this into space or 3 dimensions, we would then be talking about the equation of a sphere. So the concept, if you were centered at the origin, the point 0, 0, 0, we would have x squared plus y squared plus z squared is equal to whatever the radius is squared. The equation of a circle was always a variation of the distance formula, so the equation of a sphere is also a variation of the distance formula. So radius, now what symbol should we choose for radius? And I'm leading you on because in the English language R stands for radius, and we certainly can use R for, how about we stop after this video? Let me just tell you. The book even uses R for the moment. But within just a few sections, the book is going to stop using R for radius, and it's going to use the Greek letter rho to represent the radius of a sphere. We're going to continue to use R for the radius of a circle. But so when I put the or here, it's not really an or that you get to choose. We are going to use this anytime I do an example. This radius will be called rho. In the last chapter of the course, there are some problems where we interchange between different coordinate systems, and this letter R has a designated meaning, and it is not the radius of the sphere. So I don't want you to practice a bad habit that you're going to have to change. Use this symbol for radius as we move forward. But you could certainly find other books where this might be the symbol and this might have a different meaning. Rho gets used more than once this semester, just so you know. We're recycling. Now, if it's a sphere that's centered at some other point, x0, y0, z0, and there is a radius equal to rho, then that equation, x minus x0 squared plus y minus y0 squared plus z minus z0 squared would equal the radius squared. Looks a lot like our circle. That's pretty good news. It's very, very similar. Now, we're not going to do a lot of graphing of spheres, but there's one type of sphere that we're going to sketch a fair number of times during the course, and that would be any sphere centered at the origin. So let me kind of come back up here and just sort of highlight that. This one's more important than the others. So if we were to sketch the sphere x squared plus y squared plus z squared equals 16, don't start with the axes. We're going to just try to get something that looks like a sphere. So we're going to do a circle. That's what it would look like from the side view. And we're going to do what I call giving it a belt. So this is supposed to represent sort of looking down from the upper hemisphere on the globe, so to speak. And if you want to see the back part of the belt, I usually use a dotted line or some sort of a dashed line. And then we could put our z-axis and our x-axis and our y-axis on afterwards. And for this particular problem, the radius would be, well, that's right, the radius would be 4. I'm just going to label it one place. A sketch of a sphere is never going to be any fancier than what you see right here. It's going to be very simple. Circle with a belt, put the axes on, call it a day. It's good to go. Now, sample. We're going to write the equation of a sphere that has a particular center, and here's another point that is on the sphere itself. So we know the location of the center point, and we know that some other point on the sphere is this point here. What we don't have specifically is the radius, the distance from the center to that point. So, but we do have the tools already. Doesn't take us long to get there. So, x minus 3 quantity squared plus y minus 4 quantity squared plus z minus a negative 2, which should be z plus 2 quantity squared equals, oh, I need to have my radius to square, don't I? Well, the radius is nothing more than the distance from the first point to the second point. And if those coordinates look a little bit familiar to you, well, they should look familiar. So this is from before. So this is a previous example all of a sudden where we calculated the distance between those. And there's several ways we could do it. We could actually put 0, 9, 0 in here and find the radius that way. But we already have the radius, which was square root of 38. Again, I'm recycling some information here. So I could write square root of 38 quantity squared, or I could just say equals 38. I'll accept this as a final answer, or I'll accept 38 as a final answer in terms of that. So there you go. There's the equation of the sphere, whose sketch we didn't really do. I only used this picture to sort of represent how the given information is applied. Now, one more sample. Here it is. This should bring back some old algebra memories. How do we take this algebra and convert it into something that looks a little bit like this algebra? Once again, you are correct. We are going to complete the square. So I'm going to combine my terms with x in them, and my terms with y in them, and my terms with z in them. Equals, and let's just move the 10 over here. And because I'm having to write a little bit larger for recording purposes, I don't really have quite enough paper to write this in a make your teacher happy sort of way. But I am going to make it fit here. So if we complete the square, minus 4 plus, that's 16. But you can't just add 16 here. You must also add 16 here. And let's see, half of 2 is 1, 1 squared is 1. But you can't just add that 1, you have to add 1 here. Half of 5 is 5 halves. That's going to be 25 fourths. So we will add 25 fourths here, or 6 1/4. When we combine this fun little mess, I have x minus 4 squared plus y plus 1 squared plus z minus 5 halves squared equals, let's see, that's going to be 6, it's going to be 7, that's 28 fourths, and 25 fourths, it's going to be 53 fourths. So here is our equation. Now, breathe deeply. I haven't answered the question yet. Center and radius. Well, my center is going to be for -1, +5 halves. And my radius is going to be the square root of 53 over 4, or square root of 53 divided by 2. There you go. There's some basics. Algebra should look very familiar to you, and in particular, knowing the basic equation, sketching if it's centered at the origin, being able to find the distance between 2 points. Those are some key skills that we're introducing to. One more little piece to go with three-dimensional introduction, and then we'll do, well, I don't want to give it away. You'll have to come back and find out. Until next time.